Hello student and welcome back to my YouTube channel Pinnacle. Today we are going to solve the AC circuit Thevenin's equivalent at terminal X and Y. Normally students afraid how to solve the AC circuit problems. So today I am going to tell you the simple way that by using that simple techniques you can solve the problems for AC circuits. So the first thing is, what are the steps to solve Thevenin's equivalent circuit? If you are not aware about what is the concept of Thevenin's equivalent circuit, then please refer my previous videos. Those are explaining the Thevenin circuit, equivalent circuit, and the steps, basic steps, those we are going to follow to find a circuit. So the first thing is that for any circuit, it is a circuit, we are interested to know that what is a equivalent or at a particular point, means if these are the point, then those 2 points, what is a voltage and impedance. So to find this, we are having a first step, find open circuit voltage at given terminal, means in this case this one terminal and this is second terminal. And second step, find equivalent impedance. Okay, and third, redraw the equivalent circuit. So in a Thevenin's equivalent circuit, we are having a impedance, okay, and we are having a voltage. It is Thevenin's voltage and this is equivalent impedance. So this is my Thevenin's equivalent circuit. The total circuit is going to convert into a single voltage source and a single impedance, equivalent impedance. Okay, so we will start to solve the numerical. So this is our numerical. In numerical, it is given that my voltage source is 10 volt, okay, and it is 0 degree. Okay, then R1 is a 10 ohm, R2 is a 3 ohm, inductance is a 4j ohm, okay, and capacitance is minus 10j ohm. Okay, and this is X and this is Y. So these are the terminals where we want to find the Thevenin's equivalent circuit. So the first step, find open circuit voltage VOC and in our case VXY. So to find that VOC or VXY, when we completed this open circuit, then we want to find the current flowing from this impedance, okay, and the voltage is nothing but a impedance into current. Okay, so to find this current, this is loop current I. Okay, this I is going to flow from this resistor and impedance. So to find I, we know the formula is current is equal to voltage divided by resistance, and here it is impedance because it is AC circuit. So my formula is voltage divided by impedance, okay, Z. So here voltage is only 10 volt and my impedance is 10. I'm starting from this point, okay, so it is a 10 plus 3 ohm, next is a 3 ohm and plus 4j. Okay, this is a rectangular, so we know that division is very simple in polar form, so we converted this into polar form. So 10 divided by 13 plus j4, it is converted into polar, so it is a 10 degree is a 0, then it is a 13.6. In calculator we can find this value and there is a directly conversion rectangular to polar. You can find this answer on your calculator and directly here we are having a division, so 10 divided by 13.6, it is 0.735, and angle is 0. We know that in an angle division directly minus whatever dividend. So it is a minus 17.1 degree. So this is current, that why unit is an ampere. Don't forget to write the unit because it is very important. Whenever you are solving any numerical, you should be very clear what is your unit. So now next we want to find the voltage VOC or VXY. So VXY is equal to current I, okay, and here impedance is multiplication Z is nothing but I into 3 plus J4. So putting the values of a current 0.735 angle minus 17.1. When we converted this rectangular 3 plus J4, my polar is 5 angle 53.13 degree. So that's why this answer is 3.676 if you calculated on calci, angle 36.03 volt. So this is your answer for voltage, okay, and this is your answer for equivalent current. Now next step is we want to find the equivalent impedance at terminal XY. Okay. So for that we have to remove the voltage source. So after removing voltage source, here is a 10 volt. Okay. Then here is a 3 ohm. Then impedance. The circuit is complete. Then capacitance. Okay. So it is 3 ohm. It is the impedance J4 and this is minus J10. So to find Z equivalent, if you observe the circuit, then we are going to look the circuit from this side. Okay. So that's why from this side, if you observe that this impedance is series with entire circuit. Okay. So that's why I'm started writing that minus J10 series with this circuit, but in this circuit 3 plus J4 and 10 ohm are parallel. So 3 plus J4 parallel with 10 ohm. So this is minus J10 plus 10. We converted this into polar. Okay. So it is a 0 degree. Okay. Into 553.13 degree divided by 3 plus J4 plus 10. So we solve this example. So it is minus J10 plus 50 angle 53.13 divided by 13.6 angle 17.1. We converted this into polar form. So now we are getting minus J10 plus 3.676 angle 36.12 degree. Okay. We can directly convert this into rectangular form. Okay. And you can perform addition with minus J10. So we converted this into polar to rectangular. So it is minus J10 plus 2.969 plus J 2.167. So the whole answer is equivalent circuit 2.969 minus J 7.83 ohm. So this is nothing but Z equivalent for this circuit. So now we have to redraw the circuit. So this is your source, okay, and this is your Z equivalent. This is your VTH and Z equivalent. So we have the value for VTH is equal to 3.676 angle 36.03 volt, okay, and Z equivalent is 2.969 minus J 7.83 ohm. So I hope that after watching this video you can solve the Thevenin's equivalent circuit. Thank you.